In the previous episode, we learned about functions, and now we shall study about what are the various types of functions. Now, suppose we have a function f from set A to set B, then remember a function f associates or links all elements of set A to element in set B such that an element of set A is associated to a distinct or a unique element in set B. So now you can see if we follow these conditions, then different combinations of functions can be formed from set A to set B. In some function, you will find that distinct elements of set A are associated to the distinct element in set B. In some cases, you will find that distinct elements of set A are linked to same element in set B. In some cases, you will find that there are elements in set B which have got no pre-image in set B. But there will also be the cases when all elements in set B will have some pre-image in set A. Now, since various kind of these combinations are possible, so this gives rise to various kinds of categories or types of functions. So the first type of function which we are going to study is called as injection or one-to-one function. Now a function f from set A to set B is said to be a one-one function if different elements of set A have different images in set B. That means if f is a function from set A to set B and if it is 1 1, then this is possible if and only if A is not equal to B, then that means f of A is also not equal to f of B for all A and B which belong to set A. Or you can say if f of A is equal to f of B, then that means A is equal to B for all A and B where AB belong to set A. So that means if value of a function is same for two numbers A or B, then this is possible if and only A is equal to B, where AB belong to set A. Or in other words, we can say a function is 1 1 if and only two distinct elements of set A have distinct images only. And now look carefully at the figure on the screen. Here you can see we have got four functions from set A to set B. And now we shall check whether these are 1 1 or not. So in the first function you can see each element of set A has got a distinct image in set B, like A is linked to P, B to Q and C to R. So that means first function is a 1 1 function. And in the second case we have got A and B from set A are linked to P. So that means A and B are linked to the same element in set P. So that means the different element in set A, which are A and B here, have got the same image P. So that means this is not a 1 1 function. So this doesn't satisfy the condition for a function to be a 1 1 function. That means the second case is not a 1 1 function. In the third case, you can see A is related to P and B to Q and C to S. So that means different element in set A are linked to different element in set B. So that means the case 3 is a 1 1 function. And the fourth case you can see again this is also a 1 1 function. And here you must have noted one thing, that it was quite easy for us to find out whether given function is 1 1 or not. because the number of elements in set A and set B in the given examples was quite small. But what if the number of elements in set A and set B is quite large? And what if the number of elements in set A is infinite? So you can see it will be quite difficult for us to check whether given function is 1, 1 or not. So there must be some step-by-step approach or some kind of algorithm to check whether a given function is a 1, 1 function or not. So now let's learn about the steps or algorithm to test whether given function is 1, 1 or not. We can check whether given function is a 1, 1 function by following 3 steps. In the first step, we take any number x and y in the domain of f, and in the step 2, we put f of x is equal to f of y. And in the last step, we solve f of x is equal to f of y. And if it gives x is equal to y, then we say the function is a 1, 1 function. And now let's solve some questions by using these steps to check whether given functions are 1, 1 functions or not. Question number 1. Check whether the following functions are 1, 1 or not. First case, function f from R to R, where f of x is equal to x cube plus 5 for all x which belongs to real number. And the second question is the function from z to z, where f of x is equal to x square plus 3 for all x which belongs to integers. So let's first solve the first part. Suppose we have x and y which belongs to real number in the domain of real numbers. Let's assume fx is equal to f of y. Now f of x is equal to x cube plus 5 and f of y is equal to y cube plus 5. Now here f of x is equal to f of y, or we can write x cube plus 5 is equal to y cube plus 5. And crossing out 5 from both sides, we have x cube is equal to y cube. Now x cube is equal to y cube if and only x is equal to y. So that means the step 3 condition is satisfied. So our final condition x is equal to y is satisfied when f of x is equal to fy. So that means f is a 1, 1 function. Now let's solve the second part. Suppose xy belongs to integer in domain of integer and f of x is equal to f of y. F of x is equal to x square plus 3. F of y is equal to y square plus 3. And now since f of x is equal to f of y, that means x square plus 3 is equal to y square plus 3. Or we can say x square is equal to y square. Now x square is equal to y square, and now you know it very well. If x square is equal to y square, then x is equal to plus minus y. You can also check it. Suppose we have got x as 3, then the value of f3 is equal to 12. Similarly, the value of f minus 3 is equal to again minus 3 square plus 3, again it is equal to 12. So that means the given function has got same value for different value of x. Or we can say this function has the same value for different value in the domain of given function. So that means this function is not a 1, 1 function.